transform it, do a little change to it, and show the graph of now x squared plus 2 in no time. Now, most of us, I think, just common sense would say, Professor, I think even before Michael reads the rules here to follow, this really says take that graph and lift it up 2. So what's the big deal? Just take that basic graph given to me, the red one, and lift it up 2, and say, no problem here. I'll do it like this. And you'll say, Professor, can I just do it like this, something like this? And see if you guys would accept, is that all they're saying to do? Take the basic graph and lift it up 2, vertically shift it up 2, and now have this as y is equal to x squared plus 2. And I'm gonna have him read to it shortly here, but that's just a little common sense. Number 2 says, I'm gonna try this one in green, and I suppose it looked like this. A little introduction to transformations. Now suppose the 2's inside. Now this one, and some students may recall, when you did all these, may recall what's happening here. Now suppose it says x plus 2 squared. I don't want you to expand it, I just want you to show me a graph of, based on that red graph. The red graph is like the parent graph. Does anyone think they know what should I do? On the last one, I just merely shifted it up 2. I got the blue one. What do you think I'll do for the green one? You get this one. I wonder what that 2 this time tells me to do. Not vertically shift it up, I've already done that. What do you think the 2 might tell me to do in this case? And then I'll have Michael to read for us. Any ideas? What the 2 this time tells me to do on the red graph? To transform it? Any ideas? Okay, Michael. Idea, yes. She said, Professor, I think I remember this says transform. Move that red graph horizontally 2 to the left. Okay, so if I move over 2 to the left, here's the suggestion. Professor, I think we'll do this. Move over 2 to the left and have your green graph to look something like this. Does that look like the red graph has been shifted over to the left 2 spaces? Now she says she thinks that's what it means if it's written like that. I'll try one more before I have Michael read for me. Does anyone think they might recall next one may look like this? Y is equal to a negative sign out front of x squared. What effect, what transformation might that negative sign stuck out front tell me to do in terms of the red parent graph? Any ideas? And we'll do it, I'll try to find the color here, we'll do it. What do you think, guys? What does the negative sign stuck out front tell me to do? Any ideas? Then we're going to have him read the rules to us here shortly. That's all I hang one up.
Will you reverse it, like flip it upside down?
Oh, beautiful. So you're saying, Professor, I think it means, you described it as being flipped upside down. I think Professor means that. The red graph is being flipped upside down. We call it reflected through the x-axis. So if the negative sign is stuck out here, it says reflected through the x-axis. In other words, flip it over. Like my student just told me. And that's just a few transformations. Take a graph and transform them. Michael. Guy, could you read for us, I have the steps that are listed, I think. Read for me the first transformation that I have listed there.
Vertical shifts of graphs.
Yes.
To graph y equals f of x plus c. Shift the graph of y equals f of x upward c units.
This is exactly what the x squared plus 2, that was the transformation this one gives. This is f of x plus c, they call it. Read the next one.
To graph y equals f of x minus c.
Now, hold on. If this had said x squared minus 2, then finish that up.
Shift the graph of the y equals f of x downward.
Now you will shift this graph down here to negative 2. Easily done. The vertical shift is very easy. They call this vertical shift. Read the next one.
To graph y equals f of x plus c, shift the graph of y equals f of x to the left, c units.
Yeah, it's x plus c, they call it c, and I use my c to be a 2 for my example. That's c. And they're saying if it's x plus c shifted to the left, many students will think, and I probably as a student probably thought way back, if I saw a plus sign, that might mean to shift it to the right. A plus, professor, horizontally shifted to the right, even though on this one, a student told you earlier shifted to the left. So guys, if it's a plus, you're going to shift it to the left, which looks like it's so opposite. Does anyone have a rationale why? Looks like it says plus 2, it says 2 to the right, 2 to the right, horizontally. But we went 2 to the left. Wonder why they say do that? Give me a good rationale why do you think they say if it's x plus 2 in my example, move it 2 to the left, not 2 to the right.
Because of the 0 problem.
Because of 0. What would I have to replace x by here to turn this into a 0 here? Is that -2? And did we actually land at -2 here? So that's the rationale behind there. So I just got to recall, if it's plus, you're going to go to the left on a horizontal shift. Read the next part.
For graphing y equals f of x minus c, shift the graph of y equals f of x to the right.
So guys, if this has been a minus, he says if it's a minus, the rule says shift it to the right. So now my green graph would be over here 2 to the right. If it had been a minus. Now this thing's going to get a little stranger. Be careful. What's next?
Reflecting graphs. To graph y equals negative f of x, reflect the graph of both y equals f of x and the x-axis.
That's exactly what we did. We had to reflect the graph, the ray graph through, flipped it over the x-axis. That's all we did, just flip it over the x-axis. They call it reflection through the x-axis. Now, I don't have one up here yet. Michael, tell me on the side here, what's the next one?
Graphing y equals f of negative x.
Hold on. I gotta discuss this one. Where the negative sign's inside, not out front like it was on this one. Where we reflected through the x-axis. That's easy. Guys, if the negative sign is caught somehow inside, he's gonna read it to me though. What do you think's gonna happen? We saw a reflection through the x-axis earlier. What do you think the negative sign caught inside might be telling me to do? Michael, go ahead and read that to me.
Reflect the graph of y equals f of x and the y-axis.
Oh, reflect this time through the y-axis. Now the parabola, my red graph, guys, this is not a good example here on this. The red graph, I saw what you did when you reflected through the x-axis, you just flipped it over. If I reflect through the y-axis, that means take this piece on the right to the left, take the left to the right. You're going this way on the y-axis, not the x-axis, this way on the y-axis. In this particular case, would that give me the same graph you see right now? If I reflect my red graph, I'm calling it my parent graph, along the y-axis, am I going to end up with the same graph? Now some graphs, of course, you'll end up with something different, but this one's just a basic parabola. Okay, so tell me more now.
Horizontal stretching, shrinking.
Oh, that's the hard one. Okay, jot it down, read that to me.
To graph f of cx.
Whoa, 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 whoa. Okay? Very hard.
C is greater than 1.
Whoa. C must be greater than 1.
Shrink the graph of y equals f of x horizontally by a factor of 1 over c.
So this is a horizontal, they call it horizontal shrink. By a factor of how much?
1 over c.
You talk about madness? That's the one that's going to drive you nuts. I have not shown it up here yet. Okay, Michael, did you read for me? Tell me the next one, then I may slow down and start talking about these. The next one says what? F of
c of x,
okay, f of cx again.
where 0 is less than c, so less than 1.
Whoa, like this. Okay,
Stretch the graph of y equals f of x horizontally by a factor of 1 over c.
so this is a horizontal stretch, not a shrink. By a factor of one over C. Now, those two are what require a little time to do. Now, we'll do one when we break into groups to finish this up. Were there any other transformations listed, Michael, on that page?
No.
Okay. Now, let me ask you, I didn't place these on there. Can someone tell me, where am I? Back here. If, for example, can someone describe for me, and it's not on the handout, I did it on purpose there. Suppose I asked you to sketch this. 2x squared. Just out of curiosity, what do you think the two placed directly out front? Right here. Not out here. That's the vertical shift. Not inside. That's the horizontal shift. Not any of this that he's talking about here. Out front. What do you think you have to do to show the effect of a two placed directly out front? Now, I'd like for someone to use the correct vocabulary. What do you think it is? It's not a vertical shift. It's not a horizontal something went on. What do you think the twos directly placed out front will do to my graph?
Compression.
So again.
Compression.
Oh, get close. What do you think? Okay, let me do this for you. Let me go back to my basic red graph. Now I'm using for my parent graph. That's the X squared graph. And I'm standing right here, guys, and ask us to please go to that red graph, find a few points on the red graph, and multiply the y coordinate by 2. Multiply the y coordinate by 2. Let's start with 0, 0. 0, 0 is on that red graph. If I take the y coordinate and multiply it by 2, right here, do I still end up with 0? 2 times 0, will that give me, let's see if I can put it in this color.
What, expanded?
Will that give me 0, 0 here? Please tell me on the red graph, is the point out 1, up 1 guaranteed to be on the red graph? I replace x by here in the red graph. If I replace x by 1 and square it, do I get a 1? So am I guaranteed 1, 1 is on the red graph? If I multiply the y coordinate by 2, now where is it? It was 1, 1, that becomes what? 1, 2. So it's out 1, up 2, so it's maybe here. -1, up 1 is on my red graph, guaranteed. Place on my parent graph x with a -1, you scratch to get a 1. So -1, 1 is guaranteed to be on my red parent graph. If I multiply the y by 2, does that also at -1 go up to 2? Yes or no? I do see an effect of some sort. For 2x squared. Whoa. They call that a vertical stretch. Not shift, a vertical stretch by a factor of, in this case, 2. A vertical stretch by a factor of 2. Because we're going to multiply the y coordinates by 2, connect, and you see the effect that that had on your parent graph. So that was not on the handout. And I held off on that till I finish this thing up tomorrow, not tomorrow, Wednesday. Now, can someone tell me, before we leave this, Michael, this is a strange one. If they say graph this, the 2 is inside, not out front. It's inside. Now he says, Professor, they say to get the effect of this, it's the transformation of the graph. To get the effect, if C is greater than 1, here's the rule. Yeah, my C, I chose to be a 2, that's greater than 1. Then it should be a horizontal shrink, it should shrink the graph by a factor of 1 over C. Now, what on earth would that mean for a student to read this on your own? Open up a textbook on your own. I would love for you guys to just open up your textbook and I could just give quizzes. And I wouldn't have to lecture at all. You just report in on Wednesdays. You have Mondays off. Why? Because my students are reading the textbook and they understand every word in that textbook. Just come in on Wednesday, take a quiz. Wouldn't that be wonderful? It's not gonna happen. Because when you sit down and try to read a math textbook, no way. Not the way math is written in a textbook, you're not gonna understand all that. That's why we're here, and the math lab is here. My two TAs are here. We gotta break it down to something else and show you how simple it might be sometimes. Just break down what the math textbook says and try to break it down and show you what it really, really means. Guys, this one's tough. And then this one also he gave me is tough. That 1 over C to get a horizontal shrink or a horizontal stretch, a factor of something. Now, with all that said, he says that's all the transformations I have there. Guys, please flip that over. Is it something on the back? Oh, is there something on the back? Look at this. I gave you a parent graph.